We replace the combustion tube, and I will now start the flow of hydrogen gas. I allow the hydrogen gas to flow for a short while so that we do not have a mixture of air and hydrogen, so that I can safely ignite. The hydrogen gas is being turned on. I leave it for a few seconds and carefully reignite. The reaction doesn't occur in the cold, and so we need to heat the copper oxide. So we will light a Bunsen. Initially we will heat with a small flame, but we will build up the heating throughout. So initially a fairly small flame, and we'll start to heat the copper oxide. As I heat, I need to make sure that I capture all of the copper oxide and try to make sure that I convert all of it into copper. So what's happening at the moment is the hydrogen gas is passing over the copper oxide. The reaction doesn't occur in the cold, but if I warm this, you may be able to just see that the copper oxide is changing from black to a pinky brown colour, which is the formation of the copper. Let's just go out. Just make sure we get all of the copper in that area formed, and then I will move further down the tube, heating that a little bit harder. So that the black copper oxide everywhere is converted into copper. So at this point I will just increase the Bunsen flame to try and help ensure that all of the copper oxide is converted into copper. You can see that there's a little bit of black copper oxide at this end of the tube, and you may see the flame go slightly green as there's an inevitable loss there as a result of the copper atoms being picked up by the gas, and you get the typical flame colour of copper of being that blue-green colour. Okay, so plenty of the copper oxide has now converted into copper. So we will just raise the heating level still further to see if we can get more and more of the copper oxide converted. Finally, absolutely at full pace on the Bunsen. Now, when we finish this experiment, the chances are not all of the oxygen will have been picked up by the hydrogen. So not all of the copper oxide will have been converted to copper. To ensure that we have done this, we would, after the first weighing, which we will do in a second, of the copper and the combustion tube, we would put it back onto this equipment and we would heat again. If after further heating it has the same mass, we can be fairly certain that we have driven off all of the oxygen. All of the oxygen has been removed. This is called heating to constant mass. However, if we didn't get the same mass and it had gone down further, we would need to put the combustion tube back on again and again until eventually you reached constant mass. In this video, we will just heat it once and use the results from one heating, which will clearly be a little inaccurate. When we come to the end of the experiment, it is essential that we do not turn out the hydrogen gas while the copper is still hot. Copper plus air or oxygen, the 20% of the air which is oxygen, would react together to reform the copper oxide, which we have just converted into copper, which would obviously alter the result considerably, and we would see some black copper oxide. So as we finish the experiment and we prepare for our first, on this occasion our only weighing, we will turn the Bunsen out, but we will leave the hydrogen gas still flowing. And as you can see, there is plenty of copper having been formed, but maybe also some signs that there may be a little bit of black copper oxide left. So we need to leave this until it has cooled sufficiently that the copper will no longer react with the oxygen in the air. And this is difficult to judge, but we will leave it for a short while. We will try after that relatively short period of cooling. So we will turn the hydrogen gas out and I will weigh the combustion tube with the copper in. As you can see, plenty of copper has been formed. So it is certainly true, copper oxide plus hydrogen produces copper, and the other product is of course H2O, but in the gaseous state. And so if you'd like to take that final reading, that is the mass of the combustion tube and the copper that we have produced.